Okay, let's put it all together and make sure that we can identify each of the different types. Okay, so if I look at 42, what I notice is I have a function in a bracket to the power of 3. So let's just check. Is this one where you have the function and you have the almost derivative out the front of it? And it is, because the derivative of a quadratic is a linear. So this is that second type that we went through just a couple days ago. So what I do is I begin by writing the integral of, I write down the function part to the power of 3. And what I write out the front is what the derivative should be. So what it should be is 2x take 2. But that's not what I have. I have 1 take x. So not only is the terms switched around with the negatives, what I have in my actual question is only a half of what I should have. So out the front, I need a negative to switch the negatives around, and then I need to halve all this so that I end up with what I wanted. Once I've done that and I've adjusted it, I get into the antiderivative. So it's negative a half, and then I have x squared take 2x plus 1 to the power of 4 over 4 plus c. And then I can simplify that. So I have negative x squared take 2x plus 1 to the power of 4 over 8 plus c. Okay, if I look at the one next to it, 28, it sort of looks like 42, except for I have linear inside the bracket and linear outside the bracket. So 2x is not the derivative of 1 plus x. So for this type, I need to actually simplify before I can do any antiderivative. So I have 2x and I have 1 plus 2x plus x squared dx. And I'll keep expanding at this point and simplifying. So 2x plus 4x squared plus 2x cubed. And now I'll anti-differentiate. So I'll have 2x squared on 2 plus 4x cubed on 3 plus 2x to the 4 on 4 plus c. And we can just simplify that to be x squared plus 4x cubed on 3 plus x to the 4 on 2 plus c. And if I look at my final type here, 54, first of all, I would want to rewrite this such that it is 6, 1 plus 2x to the negative a half. So anything in the denominator, you want to bring it up. And then what I notice is what I have in the bracket is linear, and there's no x's out the front. So this is the one where I can use that linear rule that we did a few days ago. So I'll have 6, 1 plus 2x, add 1 to the power, so that's 3 on 2, divide by the power of 3 on 2, multiplied by the derivative of what's in the bracket, or the gradient, which is 2, plus c. And so these 2's cancel out, and 6 divided by 3 is 2, 1 plus 2x to the 3 on 2, plus c.